I'm going to take a closer look at the 3 batteries that I have here. First, the 2 packs from our recommended items list. The larger one claims to have 6 amp hours and the small pack has a sticker that says 1.8 amp hours. These kinds of packs come with a cable that you can use to connect to your robot. Alternatively, in your kit, there is a 5.5mm barrel plug for you to make your own cable. For a quick first setup, you can just use some jumper wires to plug it directly into your breadboard. And then there's this third pack. This specific one has bullet type connectors for the 12 volts. We'll get to that later. What I want to know is how much current these packs can source. To find out, I'm going to connect them to this thing here. This is an electronic load. It's an instrument that simulates an adjustable resistor. This specific one has a voltmeter and an ammeter, and it can dissipate up to 1500 watts of power. After connecting it, I power up the battery and the load. Then I hit the green button on the right and the battery is now connected to the instrument. I can see the battery voltage. I've set the range for the voltmeter to 18 and the ammeter to 12. Now when I turn this knob, I can change the impedance of the load and slowly increase the current. Let's find out what happens when I draw more current than what the pack is spec'd for. Boom! Did you see that? Just a bit more than 2 amps and suddenly voltage and current are gone. I have to turn the pack off and then back on to get my voltage back. And then to make sure that this is normal behavior, I repeat this a number of times. And yes, so this is the first result. My small pack is good for up to 2 amps, but it will turn itself off at a higher current. And I'm sure it will also turn itself off when it's empty, meaning when the battery voltage is getting low. Next up is the larger pack, the 6 amp hour capacity. Surprisingly, this pack can do up to 6 amps, which is quite a lot. And I say surprising because it's only rated for 3 amps, at least that's what the label says. But the important part for us is that it has an overcurrent protection and that it can be reset by turning it off and then back on. So to recap, this battery, at least the one that I have, is good for up to 6 amps, even though it's only rated for 3. The third battery is an interesting one. It runs the same voltage as the other 2, but this monster is rated to give up to 400 amps. That's enough to jumpstart a car, which is exactly what this pack is made for. And how can it do that? It's because of the type of cells in this pack. They are called prismatic cells, meaning they're usually boxy and flat. They have thicker electrodes and a far lower impedance, and also they have much beefier taps that allow for a higher current. The other packs use cylindrical cells that are good in terms of capacity, but they cannot source more than a few amps. For testing, I'm using the massive alligator clips that come with the pack for starting a car. There's some kind of safety relay built into the cable. One has to hold a button for a few seconds to turn it on. I'm changing the range to the ammeter to 36, so if the needle goes the right side of the scale, that means there are 36 amps of current flowing. I'm ramping it up, and pretty soon after I'm getting to around 30 amps, I'm noticing that the wires are getting warm, at which point I'm turning it off. If you want to use a pack like this for your robot, you must add a fuse. I will show you in another video how to do that. Without a fuse, a pack like this can easily get you in trouble if there's something wrong with your circuit. I'll show you now what 30 amps look like when they flow over wiring that is a bit too thin. And for that I'm repeating the last run with an infrared camera. You can see how quickly the wires get hot. Now imagine you had a full short for some reason and this wasn't just 30 amps but 300 or 400. There's a lot of power in this type of battery, and because of this battery's special purpose, which is to start a car, there's most likely no fuse at all inside the battery. Or if there is one, it has a rating that is way too high for your purpose. The last thing I found out when testing this battery was that the safety relay will actually turn the connection off after 90 seconds. To turn that back on, one has to disconnect it and then hold the button again for several seconds. That would be super disruptive when working on a robot, and it's another good reason to make a custom adapter with a more conventional fuse.